All right, today we start part 2 of the course, which is about industry location, which includes, today we talk about location clustering, and we'll move through transport and logistics, and we'll get to retailing, which is something everybody's familiar with and has a whole world of its own. So we'll start with industry, we'll go through distribution, transport, and get to retailing. But it's all about the production and movement of goods. We're not talking so much about, I'll say a couple things about services, but not so much today, or this section. So this for the next 2 weeks, lectures 5 through 8. Okay, so today's lecture 5 on localization of industry, or places of production. Okay. So our keys today are that there is a logic to industrial location. There's a kind of calculus. It's like the classic economic calculus about why you might locate a factory one place or another. And we'll go through that, but it turns out that calculus is not sufficient at the level of the individual factory. And we have to look at dynamics of industry, and then we have to look at collective logics of industry when we talk about clusters and industrial districts, which is a very important theme in economic geography today. So we'll start with the simplest and work up. And I don't actually recommend bringing sandwiches to class, but go ahead this time. But I don't think it's a good idea. Coffee, yeah, we all need coffee, right? Okay, so we have 4 topics today: sites, places, clusters, and districts. So first 2 kind of go together, and the second 2 go together here. So start with sites, 3 topics, subtopics, industries, locations, and what I vaguely call multiples, which isn't couldn't come up with a better term. You'll see what I mean. So let's start with industries. What is an industry? Well, that actually is an interesting question, which we won't go into in great depth, but believe me, it's not obvious, and yet it's taken as obvious all the time. And we generally define industries, or sectors, as they're often known, by the final products they produce. So they produce cars, or airplanes, or clothing, or shoes, or computers, or computer games. All right, so those are products that, well, they're final products, but very few aircraft are actually bought by individuals, right? Most of them are bought by companies, which is a confusion. Now, components is another part of industries, and we see that a lot of parts or pieces of products are also commonly referred to as industries. You might refer to the tire industry, quite sensibly, because they sell both to the car companies and to individuals, but all tires go on cars or trucks or buses. So tires are generally recognized as an individual product. Are buttons an individual product? No, they generally go into clothing. You can buy buttons, but generally they're a secondary product going into clothing. A lot of electronics parts you never see, you never buy, they go into the final product. And yet, something like disk drives is often considered a separate industry. There's whole books on disk drives or discussions of disk drives. But circuit boards, much less. Now then we have the third category on here, besides final products and components, is machinery, or capital goods, what are always called capital goods, which you really never buy, although there are hardware stores where you can buy drills. You generally no individual buys a lathe or a power press or something like that. But you might buy a jigsaw, which could be used in industry. You would buy a sewing machine, but you wouldn't buy an industrial one. So capital goods are the machinery that goes into industry. Now, as you can see from what I said so far, that the distinction between capital goods and consumer goods, or capital goods and intermediate goods and final goods, there's 2 slightly different distinctions, can be a little messy. So what is an industry? It can be kind of messy. Now, today we're going to keep it simple and try to talk about final products up to a point. We will take that apart more in the next lecture. I see at the bottom of that last input-output tables. Yeah, that actually most products can be either final products or inputs into another product. So you can sell buttons on the market, or you can sell them to clothing makers. You can sell cars to corporations, or you can sell them to individuals, or trucks. You can sell airplanes to individuals, but you don't sell those great big ones to individuals. So big airplanes are almost always capital goods. So, but there are economists who discovered many, many years ago that you can do input-output tables of all the complex intersections between different sectors, different products. Now, the reason I don't go into that much is because it just makes things too messy, and we don't need to know that for now. There's also the problem of non-manufacturing. Now, generally, when we say industry, we think of what's called manufacturing. That is the production of goods. I will not confine myself only to that, although today I'm mostly talking about that. We will talk about transport and communications, and then not in lecture 6. I guess it is. In the next couple lectures, we'll talk about retail in lecture 8. Utilities, insofar as the provision of water and electricity, we'll talk about in the last section of the course. Business services we'll touch on in a later lecture, and we talk about labor. Finance, that's another area that has a location. All these things have locations, have locational logic. You can study it, and only part of it will we do. Some things we won't try not to touch at all, like health and education. Now, there's many kinds of workplaces, which is your basic locational unit, is some building that people are working in. Now, there are other kinds of workplaces, like pipelines, where you work along them. Many people move between fixed places, non-point workplaces. If you're a repair person for the telephone company, you're moving along the lines repairing broken wires, so you don't have a fixed workplace. But mostly when we talk about industrial location, we talk about fixed workplaces. Factories, especially in large manufacturing. Workshops is a word we often use for small manufacturing and specialty craft production. We will talk in the next couple of lectures about warehouses, and then stores and retailing, another kind of logic, and then offices, where we mostly have business services, although there's some consumer services in offices too. Okay, so there's a variety of workplaces. Again, we're mostly talking about factories and workshops today. Okay, firms, I don't have a separate lecture about the corporation, about the meaning of firms and how they operate. It's very interesting, but we just can't do everything. However, when it comes to industrial location, although there was a burst of excitement about corporate geographies many years ago, basically they couldn't prove that it made that much difference. So most corporate influences, I think, are secondary on the locational geography. You can bring up questions about that if you want along the way, but by and large, we will ignore the organization of the firm here. And firms not only can own many factories, but they can cross between sectors, where you have multi-product firms. Whether it's a car company that also produces buses, like General Motors, or it can be very eclectic firms that produce a lot of electronic products. Like Apple, I guess. How about Cisco? It mostly produces the basic infrastructure of the internet, the switching chips, servers, wiring, and so on. But it has some odds and ends in addition to that. It's not just focused on that. Okay, so now let's talk about the locations of factories, or what we can call spatial divisions of labor. That is, we have a term that's been around a long time in economics called the social division of labor, which refers to the differences between sectors and their specializations. Okay? And it's different from the internal factory division of labor. And so we have different industries that represent different production processes, different products, and those have different locational logics, different locational geographies. Because of the differences in their products, because of the differences in the inputs they require, the differences in the labor forces they require, and more. But just keep it to those three things, we'll keep it simple. So that a steel mill has very different requirements than a company making video games. Don't have a lot of heavy inputs in video games, but you do need a lot of computers. And in steel, you don't use many computers, but you need a lot of iron ore and coke and so on. So it's very, very different geographies as a result of very, very different industrial makeup. Okay, so where do you locate? This is a basic problem that's been around for a long time. The first guy to really talk about this was the brother of Max Weber, the famous sociologist named Alfred Weber, in what's now called sort of classical location theory, talking about the optimization problem of where to locate a factory. Where would you put a new factory if you had it? Given all other factories are already in place, given that the landscape already exists, the landscape of labor, the landscape of energy wires, electric wiring, the landscape of roads and water supplies, the landscape of markets, final markets, and so on, where would you put your factory? And that's an interesting question, and it does tell us some things about what we see out there in the world. It's the simplest way to approach industrial location, but it does have its merits. And it was updated in the 1950s, 40s and 50s into sort of neoclassical theory, sort of the mainstream economics by a couple other people, Walter Izard and Edgar Hoover, probably the leading practitioners of that. You don't really have to know those names, but that's where it stood. It's something that was invented way back in the early to mid-20th century. Okay, now one kind of logic is access to markets and consumers. So one thing you might want to do in locating your factory is be near your consumers. So you're going to weigh the transport costs of getting to your buyers. You're also going to consider things like weight and perishability. So the famous example is always that why are beer factories generally, classically they were very near their consumers, right? They were near their consumers because they were a lot of weight added because they had a lot of water in a bottle or a barrel of beer. So you didn't want to ship it a long way from where you made it. And the ultimate of that is the brew pub, right? Now, as it turned out for many years, also beer degrades quickly. It's fresh if it's good beer, and you don't want to go too far with it. Well, of course, during a certain period in the middle of the 20th century, we got industrial beer like Bud and Coors and so on, which can be produced at one factory in Golden, Colorado, and shipped all over the country because A, it isn't that good, and B, it's got preservatives in it, and C, transportation networks have gotten so much better you can move it around. Now, in fact, Budweiser has a big brewery up, although it is a national brand. Unlike Coors, it does have breweries in different places, so it does have a huge brewery up in Fairfield, where they ship the beer to you and around California, and it's pretty fresh. I don't know if they have another in Southern California, I wouldn't be surprised. But I do know they do it on a regional basis to kind of respect the older logic. But if you're doing a microbrew, as you know, most microbrews are quite local. Don't go more than 100 miles or so. Okay. Now, of course, if you can relax that a little bit, it's not too perishable, it's not too heavy, the main thing is simply being near a transport system that will get your product to market quickly. So here's a map from the 1930s of factories in Oakland and Emeryville. And they're all clustered, as you can see, along the railroad lines going up and down Oakland and near the port. So that they would have access to transport. So a very common pattern is to see a lot of factories along transport corridors like that, which ultimately, of course, became the highway corridors as well. And, of course, if you can see factories, and I'll come back to this, that move very long distances, and you think, oh, yeah, they're moving to China because they want to have lower costs. But actually, they're going there because they want to have access to the market. They have good product, and they want to have access to the market. And I have no idea what that picture is. Why did I put that there? It's a very good question. What the heck is that? I think it's a factory in China, which has no relation to anything. Yes. Yes, they might well move to an area that has the natural resources. So plywood factories tend to be near timber areas. Most plywood comes out of Oregon. Most chipboard comes out of the south, where they have all this low-grade pine that they chip up and put into chipboard, although they do some of that in the Northwest, too. Yes, absolutely. Now, that was my next point here, is coming to access inputs. So the other side of the ledger is, what does it cost to get your materials, your energy, your component parts, your labor supply? So where would you locate? Well, a good example of that is Lowell, Massachusetts here, which is located on the Merrimack River, had a fall line where they could generate a lot of water power when they built this complex in the 1820s. And the key thing was water, not labor, pretty standardized labor. They're going to bring in girls from New England farmsteads. And their market's just down the river in Boston, so they could take stuff down the river to Boston. Here's a map of the iron and steel industry back in probably the mid-20th century, or maybe earlier, in the United States. And it's sitting on top of the coal fields around Pittsburgh, the eastern Pennsylvania, on the anthracite coal fields, with a few outliers like Chicago and Cleveland. But most of it is on top, literally sitting on top of the coal, because that's very heavy. You want to be near your input. You coke it right there, and then you stick it in the furnaces, then you bring the iron ore in. Now, the reason you got some steel development around the Great Lakes is because the iron ore actually came from up here. You bring that down by boat, then you bring the coke up this way by train, or possibly by canal, and then you can make steel in Cleveland or in Chicago. So that's classic industrial location. Heavy industries are very good for this. They seem to fit this model very well. Contemporary electronics obviously doesn't fit this model so well because you don't actually locate on silicon mines, right? I mean, where do you get silicon? Mostly out of sand, off beaches. And actually, Silicon Valley is not in Santa Clara Valley because it's near beaches. Yeah. They don't. Oh, they have a metal casting. They use recycled metal. And the West Coast Steel and metal has almost always used recycled metal. There was only ever one basic steel factory in the entire West, and that was down at the Kaiser factory in Fontana. And it was always the highest cost factory in America because they had to ship the coal all the way from the high country, the Navajo country of Arizona and New Mexico. So case that proves the point. Oh, because of markets. Yeah, they were making steel casting parts for markets, for machine makers here and so on. So at the time, we did have some fairly large steel mills, although they always used recycled scrap. Like down in Emeryville, the Judson Steel was to make steel for the Bay Bridge because it was right there. And other things like the Bay Bridge, okay? So, of course, transport costs are very important in terms of bringing your supplies in, your resources in. So, again, transport costs are critical here. And often you simply locate near ports, near highways, near rail lines to have access. So a lot of factories just locate near good transportation and bring what they need in and ship what they produce out. And so a lot of basic industrial location is about cost minimization. That is, get your kind of best overall positioning vis-a-vis your outputs and your inputs. And generally that, in a lot of classic economic geography, that all boils down to transportation costs. But that's not going to be good enough, as we'll see. So let's get to multiples. Now, we're going to complicate the single sector model here a little bit, because no industry has one site. Okay, so when I say, where's the steel industry, there are many parts of the steel industry. And it wasn't all located, as you saw in that map, even when it was highly concentrated around Pittsburgh, there were still steel plants, basic steel, a lot of other places, and secondary steel and rolling mills and things like we had out here, out on the West Coast, that didn't have much or any basic steel. So most industries have many factories, many firms, and many locations. Well, is there any logic to that? Well, at the one extreme, and I'll go from one extreme to the other here in about 5 slides. You have gigantic factories that are so big they serve a great percentage of the world market, and there's some amazing examples of that. Today, the most phenomenal example is Foxconn, or Hon Hai, which is a Taiwanese company that has its main factory complex, and in this case, it's not one factory building. It doesn't look like one building. It's a whole series of buildings over several square, many acres, hundreds of acres, and it employs over 250,000 workers in Shenzhen, or right on the edge of Shenzhen, China, down in southern China. And what they do is they produce, part of that factory produces basically all the tennis shoes of the world. And they produce them for Nike, they produce them for Adidas, they produce them for LA Gear, whoever else still exists. LA Gear still exists? This is an overhead picture of the Foxconn complex showing you how many buildings there are. There's also a swimming pool and a hospital. I mean, this is a city in one industrial area. The most famous case in the history of the American industry was Henry Ford's River Rouge plant on the edge of Detroit, which employed over 100,000 workers. I think it reached 120,000 in the 1930s and 40s. That's a picture of it there. And basically, he put basic iron ore in at one end, and cars came out at the other end. It was an entirely integrated factory doing everything. Turned out actually to be a bad solution to the problem of producing a complex product. And we're going to look at basically other solutions like clustering, long-distance supply networks, and so on. Now, Henry Ford's was this kind of megalomaniac system. And Foxconn, by the way, has run into problems of workers jumping off buildings and so on, because how horrible it would be to live in a world like that. And people are starting to kick up their heels. Now, big integrated systems and big factories do enjoy some major economies of scale at the factory level. You know, you got one hospital, certain dormitories for your workers. You can share a lot of overhead capital in one building or one complex. Now, more typically, you have one industry putting out one product from many sites. Now, this is a map of car production in Europe, 2003. You can see all these different European countries have some car production. Now, car is kind of one product in a sense. But in the car industry, no one firm dominates. There are many firms. There may also be many input sources could produce this, as in steel. In cars, not so much. Or limits to market areas. And limits to market areas is a very important phenomenon in industrial location. So I expanded here to say, what limits those market areas? Well, transport costs could. I simply can't ship my product too far, or it degrades, or it's too expensive. Cars are pretty expensive, but frankly, that's not the reason for why there's this many car production centers in Europe. I mean, there's many more. This is just by country, right? But it gives you the idea. It's very hard to find a map, say, of all the car plants in Europe. National boundaries are a big reason. One company will be the champion of that country. It may get protections, like Renault in France. Or it may just have a market kind of allegiance. The French people buy Renaults. Most of you don't buy Renaults. Now, you have broken loose from Americanism enough. In California, we tend to buy Japanese cars and Asian cars. Whereas in the Midwest, they still have that allegiance, and you'll see many more American-made cars. So that keeps the American industry going, and kept it going even when the Japanese cars were much cheaper and much better. That's not so clear now, but it was clear for a while, yeah.
Yeah, the clarity when Toyotas are produced in the States and Ford is producing cars in China. What is American-made? Or an American
Yeah, well, we're keeping it simple now. Yeah. Yes, I know there is that complexity, but people still think of it as an American-made car, actually, and they buy it for that reason. So my point still holds, even though you're right. Perception is reality sometimes, my friend. Okay, then you can have one industry that has a whole bunch of variants of types of output within a sort of array of goods. And cars can be like this, because German cars are this set of things like, which I brought up before, another lecture, like BMWs and Audis and Mercedes, these luxury cars, finely crafted cars that the Germans specialize in. Or in central Italy, they're still making Lamborghinis. They don't have a big market, but those kind of elite cars really are not substitute for, Toyota SUVs. So that can make a difference. Different kinds of foodstuffs. We say the food industry or the furniture industry. But turns out there's one segment of the furniture industry makes metallic office furniture in LA, and another one makes wood furniture for houses and office, nicer offices and so on. And those two are actually quite separate. And yet we tend to just speak of the furniture industry. So product differentiation can lead to locational differentiation too. Now we will get into one product, many inputs, but that's in the next lecture. So my friend here will not be happy until we get there, but we will. Okay. Then there are very specialized producers who put out, because of specialized skills, know-how, patents, labor forces, and so on, generally in smaller factories and workshops, turn out highly specialized products, which have a very much more of a niche market, a limited market, a high-end market, or whatever. And these are often known globally and shipped globally from one location, even though they're small scale, because they're producing these fine products